Episode 5. Too much nickel, too much CO₂, too much cyanide, and far too much coincidence. After 4 chapters of improbable orbital behavior, negative polarization, a tail that flipped direction, and early non-gravitational acceleration, we've reached the point where nature can't smooth over the data anymore. Once you go into the chemistry, there's no room for interpretation. If the composition doesn't fit, it doesn't fit. And in the case of 3I Atlas, nothing matches what is known from natural comets. Let's dive in. Chemical Anomaly 1. An extreme nickel-iron ratio. Too much nickel. According to the spectral analysis, AVI Loeb 2025, unusually strong nickel emission lines, weaker than expected iron lines, a nickel-iron ratio far above the natural range. In nature, iron is dominant. Nickel is always a small fraction of iron. The nickel-iron ratio is extremely stable across comets, dust, and meteorites. To get a ratio like the one inferred for 3I Atlas, one would need 1. Extreme thermal differentiation, implausible for a small interstellar body. 2. Formation in an ultra-nickel-rich region, unknown in cosmochemistry. 3. A physical mechanism that suppresses iron but enhances nickel. Does not exist. But there is a 4th option, an engineered composition. Nickel is common in high-temperature alloys, electromagnetic systems, engine components, corrosion-resistant materials, protective coatings. A high nickel-iron ratio fits a technological system, not a cometary nucleus. Chemical Anomaly 2. Strong CO₂ and CO emission with very low water. AV Loeb's analysis shows that in 3I Atlas, CO₂ and CO were detected at high levels, while water emission was unusually low. In natural comets, water is the primary driver of activity. CO₂ and CO appear as secondary volatiles. Their ratio to water is extremely stable across the comet population. Even the most extreme comet ever observed, C/2016 R2, a CO monster, still showed measurable water, still displayed classical sublimation behavior, and is still considered an extreme outlier. But in 3I Atlas, strong CO₂ emission, significant CO emission, very low water content compared to all comet models. This creates a non-natural signature, too much CO₂ and CO for a comet with so little water. There is no simple natural process that explains suppressed water, early CO₂ release, thermal stability at large heliocentric distances, and consistent behavior over time. But in a technological model, CO₂ is a common working fluid. CO appears in plasma systems and composite material decomposition. The system may not rely on water at all. Activity is independent of solar heating. This composition resembles a mechanical system, not an icy nucleus. Chemical Anomaly 3. Strong cyanide, despite very low water. Loeb highlights a critical point. Cyanide was detected even though water levels were very low. In natural comets, cyanide comes from the breakdown of hydrogen cyanide. Hydrogen cyanide correlates strongly with water. Cyanide intensity scales tightly with water production. There is no known comet with high CN plus low water. Decades of measurements show frac cyanide H2O, approx. 0.003 to 0.005. But for 3I Atlas, strong cyanide water extremely low. This is not a high ratio. This is a chemically impossible ratio for a natural comet. No natural process can produce cyanide decoupled from water release. Cyanide at such large distances maintains cyanide production in a water-poor environment. But plasma-based mechanisms can. Ionization processes generate cyanide. Carbon ceramic materials release cyanide under UV radiation. Engineered layers or coatings can emit nitriles. Shock heating or plasma interactions can dissociate complex compounds into cyanide. In other words, cyanide plus low water equals an engineered signature, not a cometary one. One chemical picture, 3 system-level clues. Viewed together, the anomalies form a coherent pattern. 1. Nickel far too high, consistent with engineered alloys. 2. CO₂/CO far too high with too little water, consistent with a working fluid or system exhaust. 3. Cyanide high despite low water, consistent with plasma or engineered materials. To explain this naturally, one would need unknown differentiation, exotic formation, unprecedented sublimation physics, unexplained cyanide chemistry, and all 3 anomalies appearing together by coincidence. The technological explanation requires only one assumption: a system built from engineered metals, composites and volatiles, operating in interstellar space. Chapter 5. Summary. This is the chapter where nature stops cooperating with the data. Nickel ratio, not natural. CO₂/CO high with very little water, not natural. Cyanide high with little water, nearly impossible naturally. Each anomaly is a major red flag, but together they stop being anomalies. They become system behavior, and in the next chapter, we move to the most visually striking anomaly of all. Why did the object turn blue after perihelion?